Extrusion. All synthetic fibers are manufactured the same way, a process called fiber extrusion. The polymer chips are blended and heated to form a thick, syrupy liquid. The liquefied polymer is then forced through a spinneret, which resembles a shower head containing hundreds of tiny holes. The shape of the holes gives the fiber its cross-section and size. The polymer is then cooled in the cooling tower, where it solidifies to form filaments. These filaments are then stretched or drawn and bulked, resulting in a bulked continuous filament, or BCF. The fibers are wound onto cones and shipped to a yarn mill. There are times, for some cut-pile constructions, when the bulked continuous filaments are cut into 6 to 8 inch lengths after the drawing process, forming staple fiber, which is then baled and shipped to a yarn spinning facility. Solution dyeing. The solution dyeing process colors fiber by introducing pigments into the polymer melt prior to extrusion, yielding a fiber with color as an integral part. Solution dyed yarns are extremely color fast and resist fading from exposure to natural light, ozone, fumes, and harsh cleaning agents, including bleach solutions. Solution dyed fibers may be commingled as a part of the extrusion process to form a heathered yarn, such as Shaw's Solution Q, or solution dyed singles may be air entangled, twisted, or twisted and heat set for different visuals. More than 60% of nylon used commercially, all polypropylene, and some polyester are solution dyed. Shaw's premium solution dyed fiber, Eco Solution Q, contains recycled content, which comes from post-industrial and/or post-consumer sources. This fiber system has a lifetime stain removal warranty. Now, let's view some yarn formation options. Air entangling. Air entangling is usually the second step in solution dyed yarn processing if the fibers were not commingled at the time of extrusion. Typically, 3 to 5 ends of colored singles, sometimes multicolored and sometimes solid, are placed on a creel with the lead ends feeding into the air entangling equipment. The fibers pass through the machine at a specified rate according to the frequency of entangling required. Inside the entangler, powerful blasts of air knot the fibers together. The yarn is then wound onto a new cone and is ready for carpet manufacturing. This is a less expensive process than twisting and is used for reasons of color blending, economy, coverage, and style. Roto-twist. Roto-twisting is a method of reversing the twist on a yarn at given intervals to create a unique textured visual. The interval length as well as the twist per inch, or TPI, can be changed. Twisting and heat setting. Twisting is the process where 2 or more singles or plies are twisted together to form a yarn ready for tufting. The plies being twisted together can be pre-dyed or natural. If pre-dyed, the 2 plies can be the same color to form a solid color yarn or different colors to form a barber pole yarn. If natural plies are twisted together, they can have similar or different dye abilities. Once again, solid and barber pole are possibilities when the carpet is dyed. The twisting process consists of 1 cone of singles yarn in the bucket and 1 cone of singles yarn in the creel. In this simple process, the 2 are twisted together to form a 2-ply yarn. After twisting, some yarns are sent to be heat set, depending on the construction and desired visual of the carpet to be tufted. The fiber is under tension at all times to help secure the memory of the twist until the yarn is heat set. For those yarns that are not heat set, tension holds the memory of the yarn sufficiently. There are 2 heat setting methods currently used at Shaw, Superba and Susan. Superba heat setting is a continuous process using a chamber heated with pressurized steam that raises the yarn to the heat set temperature. 24 to 48 ends at a time are coiled on a belt which feeds the yarns into a pressurized steamer to give the yarn bulk. From this chamber, the yarn goes into an entrance cool-out fan, which removes moisture and relaxes the yarn before it travels through the heat chamber for setting the yarn. An exit cool-out fan and a box dryer are the last steps for removing the remaining moisture before the yarn exits the machine and is wound onto cones for carpet production. Susan heat setting is a continuous dry heat setting operation. The yarn is fed directly from the cones onto cables which carry the yarn through the heat setting unit, where it is heated to heat set temperature to set the twist and then rewound onto cones. The next process we're going to see is yarn dyeing, also called pre-dyeing, where color is applied to the yarn prior to tufting. Skein dyeing and space dyeing are two yarn dyeing processes used to achieve solid or multicolored effects. Skein dyeing. A skein is a length of twisted and heat-set yarn wound into a loose coil using a machine called a reel. The skein is tied off in such a manner that it can be unwound for further processing without tangling. The skeins are hung on a carrier which can hold about 1,000 pounds of yarn. The carrier is then immersed in a small stainless steel vat resembling a small beck, where the dye mixture is dispersed through the yarn for even dyeing. The dye cycle can last up to 3 hours. During this time, the yarn is bulked, giving it texture. After the dye cycle is complete, the skeins are spun to extract excess moisture and placed on conditioning racks for 15 minutes. The yarn is then ready for winding on cones for carpet production. Space dyeing. Space dyeing is used to create pre-dyed multicolor nylon yarns. It is a process in which different colors are applied along the length of the fiber or yarn at intervals. The result is a multicolor yarn that in tufted form produces patterns with random color. Shaw uses 3 in-house space dyeing operations: the Belmont, Superba SD6, and Superba MCD Twin. A steamer is used on both Belmont and Superba equipment to give the yarn bulk and open the dye sites on extra long, medium, and short space-dyed yarns. The Belmont dye applicator consists of 2 parts and can print up to 48 ends of yarn. The print paddles and dye rollers are aligned perpendicular to the yarn as it moves through the applicator. The rollers continually spin and color is applied as the print paddle pushes the yarn down into the film of dye on the rollers while the yarn advances to the next position where a new color is applied. The speed of the yarn in relation to the print paddle's position determines the print length per color. The Belmont can achieve up to 8 different colors on space-dyed yarn, though 6 is more common. When the color application process is complete, the yarn moves into a post-steamer to set the dye. A coiler head then places the yarn into loose coils onto a moving yarn belt that takes the yarn through 4 steamers 20 feet in length. The next step is a post-wash applicator that sprays water onto the yarn to remove excess dye. Excess water is removed from the yarn with the use of an extractor or vacuum slot. The belt then carries the yarn into a dryer before storing it in an accumulator. As the yarn moves out of the accumulator, it is separated into single strands by a series of fingers and carried to a winder for winding onto cones or tubes. At this point, the yarn is ready for use in carpet production. The Superba MCD Twin differs from the Belmont only in its dye application process. Spray nozzles are used to apply color in place of the dye pans, dye rollers, and print paddles. 2 spray nozzles are used for each color for a maximum of 5 print colors and a base shade. The spray nozzles are positioned above the yarn. Situated between the yarn path and nozzles is a flat metal disc with open areas resembling a missing slice of pie. The yarn moves through the dye applicator as jet spray nozzles spray dye through the disc openings as the disc spins, allowing color to flow through its openings onto the yarn, creating the spot length. Each disc is set with the opening at a different angle for proper color placement and coverage of long, medium, and short space dyed yarns. The Superba SD6 applicators are used only for short space dyed yarns due to the design of the applicator. The SD6 uses turbines that are linked together by a shaft and belt driven as opposed to the MCD jet spray nozzles, which operate independently. One turbine is used for each color for a maximum of 5 printed colors and a base shade. The turbines are set perpendicular to the yarn and spin continuously as the yarn moves underneath. The shape of a turbine is similar to a frisbee with holes drilled in its outer rim. The turbine can have 1, 3, or 6 holes, which allow color to flow onto the yarn. Some short space dyed yarns may have a base shade applied in a base box prior to printing. This base shade is in addition to the 5 printed colors and is a lighter value than the lightest printed color. Short space dyed yarns take on a smaller amount of dye and do not need as much dwell time in the steamers as do medium long and extra long space dyed yarns.